Hi everyone, here is another little instalment in our homework help section. So we've got a graph here of a periodic function, and the job I've been given is to find the equation for this function. So I'll be setting this out. Now it says here x and t, so it's a function of time. So I'll be setting this up as a by, now I could pick sine or cosine. It doesn't really matter which. I might pick sine of bx, sorry, that would be t is the horizontal variable, it's a function of time, plus c, the phase shift, plus d. Now we can get quite a few clues from the diagram itself. It seems like the top of the crests here reaches a maximum value of positive 3.2, and the bottom of the troughs is negative 3.2. So that's good. Remember that from the equilibrium position D represents the midline, and that would be the maximum plus the minimum divided by 2, literally the average. So the maximum is positive 3.2, the minimum is negative 3.2, and of course the average of those is 0. So my equilibrium line on this graph is exactly along the time axis. They're not always. Sometimes these graphs are shifted up or down. But d equals 0, that's a nice straightforward one. What about the amplitude? Well, you could probably read straight from the graph. The amplitude, of course, is from the equilibrium to the maximum. That's positive 3.2. Another way you can find the amplitude is to find the difference between these, but it's in straightforward. So 3.2, that's amplitude, not a problem. How about B? Well, B isn't exactly the same as the period, but B is related to the period. I'm just going over here where I've got some space. Remember, I don't know what that's doing there. I must have grabbed that when I did my screen shot of this graph. So B equals 2 pi divided by the period. Now, what is the period of the wave? Well, the period of the wave is one complete cycle. Now, when you've got ones like this where they start not at a nice convenient point, you have to sort of run across until you get to the same point or the equivalent point on the graph, and then we can read the period here. This would be the period. Well, they're nasty, aren't they? We've got pi over 2, we've got 3 pi over 4, and that's divided into 3 sections. What? That's diabolical, isn't it? So let's figure this out. Each of those little jumps is pi over 12. How did I know that? Well, look at this one here. From there to there is pi over 4. From there to there is pi over 4. From there to there is pi over 4. And a third of a quarter is a 12th. So each of those little steps is pi over 12. How many steps are there? 1, 2, 3, 4, 5, 6, 7, 8. So the period is 8 steps. Each step was pi over 12. Now that obviously 4 could go into this twice, 4 could go into this 3 times. So it's really 2 pi over 3 for the period. 2 pi over 3. Now that's not my parameter B, that's just the period. That's literally reading from the scale, from the start to where the cycle completes one full cycle. So I've got to go 2 pi divided by, oh, sorry, wrote the wrong number then. 2 pi divided by 2 pi over 3. Well, that's 2 pi multiplied by the reciprocal. Hey, that's handy. It looks like B equals the number 3. Yay! So B equals 3. Yep. I'm almost ready. I have X equals, amplitude was 3.2 by the sine. B equaled 3 times T. I do not know C. And D was 0. Now, how am I going to calculate the phase shift C? Well, I need to pick a value from the graph and substitute into the equation. The most convenient one to select is right there. Now, what would be the coordinates of that point? Well, the time coordinate would be 0, and the vertical coordinate, although I've scribbled all over it, it looks like it would be, there's 2, it looks like about 2.4. I'm going with 2.4. Are you all happy with 2.4? I'm sorry about, if I clean that up a little bit, maybe that'll be easier to see. I think the y-intercept, sorry, I should call it an x-intercept, the vertical intercept of the graph is 2.4. So that's going to be the value I work with. Now remember, that pair of numbers, the 2.4 goes here, 3.2 is a parameter, by the sine, 3 times t, that's 0. It really just comes down to be the sine of C. So 2.4 over 3.2 equals the sine of C. C is therefore the inverse sine of 2.4 over 3.2. I probably should have had my calculator running before this. My apologies for not being organised. Let me find my calculator. It'll be somewhere in this giant list of things. No, where is it? I can't find it. Here it is. It'll be inside this bit, and it'll be this one. Yes, that's the one. So soon my calculator will turn on, and then I'll be ready. Here we go. Let's move that over to the bin. And I need to be on radians. Yes, I'm on radians. I'll just clear everything I was doing before. Inverse sine of, and I have 2.4 over 3.2. It's a pretty horrible number, isn't it? 0.848. At least it might be that. 0.848. Here we go. I'll write that down. 0.848. Now, what do I mean by it might be that? Well, remember, whenever we take the inverse of a trig ratio, we have to consider the old all stations to central. 0.848 is an acute angle. That's the angle 0.848. That might be the value of C. But that's not the only place where sine is a positive number. Sine is also a positive number in the second quadrant, and it might be this angle here. How do these two relate? Well, remember that one is 0 and that one is pi. And remember, the reference angle in the first quadrant, of course, is in relation to the horizontal axis. The reference angle in the second quadrant is also in relation to the horizontal axis. The symmetry of the situation tells me that the angle in the second quadrant could be pi subtract 0.848. So it could be, or it could be pi subtract 0.848, and my trusty calculator will tell me what that is, except I've lost the bottom edge of my calculator. How careless of me. Here we go. Pi subtract the previous answer. 2.294. 2.294. Write that down. That's 2.294. I might just write that out. 2.294. Come on, pen. 2.294. How on earth am I going to decide which of those phase angles applies to this graph? Well, here's how we're going to do it. We've decided that the phase angle C could be first quadrant angle or second quadrant angle. We're not sure which. Well, take a look at the standard sine graph. Remember, we were using a sine function to model this. A standard sine graph would peak here at pi over 2. It would cross equilibrium at pi. It would reach minimum at 3 pi over 2, and it would complete a full cycle in 2 pi. That's your standard y equals sine of x. Which part of our graph, so the starting point on our graph here, looks to be a little bit left of a crest? Let's find a point on the standard sine graph a little bit to the left of a crest. There it is. Now, does that look like it's going to be first, second, third, or fourth quadrant? Well, first quadrant runs from here to here. It's definitely first quadrant because the starting point on the graph we were given matches a first quadrant portion or point on a standard sine graph. I will therefore reject the second quadrant answer and say that my phase shift is 0.848. Therefore, the equation of my graph was x equals 3.2 by the sine of 3 times t plus a phase angle of 0.848 plus 0. That's the equation of my graph. How will I check? Well, let me use my technology. We'll go here into our graphing choices. I don't know what that is, so we can probably throw that away. And I will type 3.2 multiplied by the sine of 3. My graph will be an xy graph plus 0.848. A little bit of rounding, but should be close enough for jazz. Let's draw that. My view window is all over the place, so I will initialize view window. Here we go. Okay, I might do the view window again. I might go for a trigonometric view window, which sort of goes minus 3 pi to positive 3 pi. I don't want that. I want to go from 0. Now, our original graph, if I recall, just went in steps of pi over... Oh, I could put pi over 4 steps. I'm just going to go as far as pi for this. So I'll make that equal to pi. And the steps, I'm going to go in steps of pi over 4. There we go. Now the y and maximum minims, they were 3.2. So I might go from 4. Sorry, if it's a minimum, it'd have to be negative 4 to positive 4. And steps of 1 should do. Let's see how that one goes. Now, I want to compare that. Let me go back to our... Well, I've lost it. Where's our picture gone? There it is. Get that handy. Get my calculator back. Let's compare that. Does it look like our graph? Well, it sort of starts there, goes up to a crest, comes down. Now, you see, remember how I've put steps of pi over 4? So that intersection point is pi over 4. Then we come back up to here, then we go up to there, and by the time we get to 3 pi over 4, we're at a crest. It looks like it's doing the job. We're done. We've got it. The equation of that graph of the form 3.2 sine 3t plus 0.848. Wonderful. Have a lovely day. See you next time.